Hi guys, welcome back to the channel. For those of you who are new here, I'm Johnny Chivers, and in today's video we're going to take a look at AWS EMR in full. This course will cover how to configure and spin up an EMR cluster. We'll then look at submitting a Spark ETL job. We'll also cover a bit of notebooks. Then we'll take a look at Hive and Pig, then step functions for orchestration, and finally a bit of auto scaling. All the resources you need are in the description below. That includes GitHub for the code and buy me a coffee for the slides. Again, completely free. With that being said, I'd really appreciate a like and subscribe as I try and grow this channel, and it lets me make this content for free. With that all out of the way and the housekeeping, let's jump on the computer and get the course underway. Okay guys, welcome to this AWS EMR full course. The slides, if you want them, are in the link in the description below on Buy Me a Coffee, totally free. Just to point out that we're actually doing a workshop booklet by AWS. Again, the link is in the description below. We have a little bit of setup work to do initially, which I have this holding slide for. So let's jump onto the console and do that configuration now. Okay guys, that's me logged into the console. The first thing I'm going to do is the setup work, as I said. In terms of the workshop section, I'm going to take you through these steps on the left-hand side, the number one setup step with the ABC now. So the first thing we have to do is set up a new VPC. So if we type in VPC at the top, it'll come up VPC Isolated Cloud Resources. Click on that, and we want to launch the VPC wizard. So launch VPC wizard. We want VPC and subnets, etc. on the left-hand side. We'll just use auto-generate. We'll leave this as default, tenancy as default as well. We'll leave this as the two that's selected. Number of public subnets. We actually only need one, but the default is 2, so we'll leave it as 2. Private subnets we can set to 0. We don't need any. None. And then make sure we have a NAT gateway with the S3. Perfect. I'm actually just going to change the name of this as well. So I'm going to change this to EMR tutorial. So you can see that we actually have a name for the VPC. So if we go through the wizard here, we have the name for the VPC, which is EMR tutorial. I'm using 2 public subnets here, US East 1, US East 1B, and that's because I'm in the North Virginia region. I'm using 1 route table, and we get to go to the internet and to the S3 buckets. Okay, perfect. That's what we need. Scroll down the bottom there and hit create VPC. New wizard's a bit confusing on the VPC. They try to help you more with the graphical user interface to show you what you're building, but I actually prefer the old way, but sure, we're here now. View VPC, and hopefully we should have that VPC up and running. Next thing we need to do is set up a Cloud9 workstation. We're going to use this throughout the course just so we're all programming in the same way on the console. These are free IDEs, or these can be free IDEs by AWS. I'm using a free EC2 instance type, so it's not going to cost us anything to use it. So type in Cloud9 at the top, and you'll see it comes up, even with my misspelling. And we want to create an environment. Oh, there you can see there's a Cloud9 instance there from when I did the Kinesis. EMR, I'm just going to call this again tutorial, just so I know what it is. Cloud9, that'll do. And then next, we want to create a new EC2 instance for the environment. Micro, so it's on the free tier. That's really, really important. Not going to cost us anything. Amazon 2 Linux is definitely what we need. Keep this on because it means after 30 minutes, it's going to actually turn off your EC2 and not cost you anything. Not that it should be because we're on free tier anyway. Network settings, change this to the EMR tutorial VPC that we just used. So that's the one we just set up. Leave it in 1B, that's absolutely fine, and hit next step. And there you go, you can see we have everything here set up. It's going to create a role for us, and we're going to create the environment. This will take a couple of seconds, as you can see. I'll just pause the video here, and then once this is spun up, we'll resume this setup. Okay, that's the Cloud9 environment set up. I'm just going to close down this welcome page here, and the majority of this lesson, not all of it, will be done off this command line. Next thing we need to do is actually go back onto the console. So I am going to open a new tab and go to aws.com again. And I want to sign into the console, and it'll take me to the console. We need to actually generate a key pair, which is a mechanism to sign in to resources securely. If you don't know what it is, go have a quick Google, key pair, and then come back to this lesson. I'm not going to go into depth of what it is. So go to EC2. We're just going to create one here. so we can all follow along together. Once on EC2, we need to create a key pair, which is down the left-hand side, and under network and security, key pairs. And then we want to create a key pair. I'm going to call this one EMR tutorial. We want it to be the RSA type. RSA type, we want the private key format to be .pem, and we want to create that key pair. You can see it's automatically downloaded into my downloads. So if I just go into my downloads really quickly, I'll make that a bit bigger. You can see that it has downloaded itself. Next thing we need to do is upload that key pair into our Cloud9 environment, and we do that by going back on the Cloud9, going File, then Upload Local Files, select the file, EMR on -tutorials, what I called it. I'm in my downloads already. Open the file. You can see it uploaded there at the left-hand side, and close out, and you can see that we have our key pair there ready to go. So once you've uploaded it, the next thing we need to do, really importantly, is mod it so no one else can access that key pair and it can't be changed. And to do that, we type in the line chmod, so chmod 400, and then we want to call the key pair by name. So if you type EMR, if you've called it EMR, hit tab, it should be the only thing there, so -tutorial.pem, which is the name of my file, and enter. And we successfully modified the key pair so no one can override the details in it, and we can use it then to log in to our cluster. In terms of the setup, that's everything on AWS. The only thing I will mention is that all the code we need is on GitHub. I'll be clicking in and out of these files as we go, depending on what we need, and we'll also be using local files that we download from here to then upload into AWS. So I find the easiest thing to do is just to download as a zip into your downloads. So that's it downloaded, and then unzip it in your downloads by double clicking if you're on Mac. And then the folder is sitting there ready to go. So we can use all those different files from my local machine. So that's just the download, the resources we need from GitHub, links in the description to GitHub itself. Okay, so firstly, what is EMR? EMR is a managed cluster platform that simplifies running big data frameworks. It stands for Elastic Map Reduce, and it's a cluster, as you can see on the left-hand side. We're going to go over some important terminology here before we spin up the cluster. There is a master node, which is a node that manages the cluster by running software components to coordinate the distribution of data and tasks among other nodes. And then we have core nodes. Core node is with software components that run tasks and store data in the Hadoop distributed file system on your cluster. So we have to have at least one core node and one master node for a multi-node cluster. Core nodes is where we store the data and do the work, and master nodes is what orchestrates those core nodes doing their tasks. Another type of node that we won't be touching in this course is a task node. It only runs data. It does not store data. So it only runs tasks on the data. It doesn't store data. Task nodes are optional. We won't touch task nodes, but it is important to know what they are. So EMR itself is a data processing framework, or it contains data processing frameworks is the better way to think about it. So on the cluster, we have different data processing frameworks that we'll set up, and then we can use these to process and analyze data. There's different frameworks, as I said, to meet different processing needs. We're going to touch Spark, we're going to touch Pig, and we're going to touch Hive in this course. And then you can see there that there's just a word from Amazon saying basically anything that is the main processing frameworks, such as MapReduce and Spark that I've just mentioned, are available on EMR. And this is constantly updated. There are many versions of EMR. Cluster resource management. So there is a thing called a yarn, which is yet another resource negotiator, and basically it manages the resources on your cluster and the scheduling of the jobs. So this comes built into EMR, and in fact all big data processing frameworks in Hadoop, and that is available to us as well on the EMR cluster. And then a word about storage, because this is slightly different in AWS depending on what you're doing. There is the Hadoop distributed file system, and that's where the data actually sits on these core nodes at all times. So the data sits on the core nodes, and that is a Hadoop distributed file system. However, what tends to happen in the world of AWS is that most people operate this EMRFS, or EMR file system, where you actually store your data on S3, acts like Hadoop, and then when you need the data, the EMR cluster reads it off S3. So that's the general or the most common way people use these clusters: store the data in S3, create your cluster, and then the cluster reads the data off S3 in AWS when it's ready. Lets you store a lot more data because you store it in S3 and then you only call what you need to the cluster. And then one last thing just to remember, there is a local file system on each of the nodes because they are computers, but they're only connected to small disks to keep things like the software and the operating system on. You don't actually touch them in the world of big data. So with that being said, let's jump on to the console and fire up our first cluster. Okay, in this next section, we're going to set up an EMR cluster just to show you where we are in the workshop notebook. It's the second section, and we're going to do A, and then we're going to do B. So back on the AWS Management Console, we need to go to EMR by typing in EMR. And we want to go create cluster. Then we want to go to advanced options. Yeah. Then in terms of what we need to turn on here, bear with me, we need Hadoop, Jupyter Hub, Hive, Jupyter Enterprise Gateway, Hue, Spark, Pig, Livy, and I think that's it. So 1, 2, 3, 4, 5, 6, 7, 8. Then we want to go next. Leave this as default. Network, you want to pick the network that your VPC that we set up is in. Then it's going to ask us our subnet, and I'm going to put it in 1B, which is the same as our Cloud9 instance. Then we want 1 master and 2 core nodes, so that should be fine. 0 task nodes is really important. And then hit next. Cluster name, I'm going to call this EMR Tut, so I know it's the tutorial cluster. Just going to leave everything else as default and hit next. Then EC2, you want to pick the one that we just uploaded into Cloud9. So EMR-tutorial is the one I want. And then you want to create cluster. A few seconds will go by. And you'll see that this is starting. This will take a few minutes to spin up. So just stay on this page, hit refresh, and eventually this will go to completed. Okay, as you can see, that is my cluster now running. Excellent. So we need to add the Cloud9 EC2 that it's currently running on into the security group of the cluster so we can then SSH in. And that's the second bit of this notebook. So we're on to part B of the workshop notebook or workshop booklet. And we're going to take these steps here to let us log into our cluster. So back on the AWS console, we want to go to EC2. And I'm just going to open this up in a new tab. And we need to find the Cloud9 instance that this is running on. So if we go into up to the top of EC2 and we go to instances, we should have a Cloud9 one running. So we can see the Cloud9 EMR tutorial. We want to click on that. Then on the Cloud9 instance that you can see, you want to copy the public address back onto the EMR console, and you want to go down to the master security group, which is here. So that's just down, and then the master security group under security and access. Once in here, you're looking for the master, which is this one here. Then we want to go to inbound rules, and we're just going to change what is allowed to access the master inbound so we can actually log into it. So we want to add a rule, and we want to look for SSH, which is on port 22, and you want to paste that public IP address of the Cloud9 instance, and I'm going to put in a note so I know it's Cloud9. Then we want to add one other rule by add rule, and then you want to look for custom TCP, which is there. Then on port 9443, so 9443, you want to allow my IP, so my IP, and this is my IP for notebook. So this is going to allow us to open a Jupyter notebook in our browser later and actually access it. So 9443 and save those rules. Excellent. Back onto the console, and what you want to do is click this connect to master node using SSH, and you want to copy the Mac/Linux command here, so Mac/Linux. Back onto the Cloud9 instance, you want to paste that in, and then you want to go right to that squiggly line and get rid of that and put in dot, hit enter, and you'll see that you can actually connect. Then type in yes. And that is you logged into EMR successfully. So a couple of real steps there. You need to get the public IP address of this Cloud9 instance, and you do that on the EC2 and finding your Cloud9 instance. That is completely the wrong tab. Cloud9 instance on EC2, the EMR tutorial. Copy that public IP address, go back into EMR, go down to your master node, then change your security groups to allow SSH for port 22 on that public IP, and then back into Cloud9 where you can actually log in as I have just done, and you're successfully on the EMR cluster. Okay, so Spark ETL. What is Spark? So it's Apache Spark. So it's managed by the Apache Software Corporation, which is obviously open source. You can go look at it in GitHub, and you can go look at it on their website. It's a multi-language engine for executing data engineering, data science, and machine learning on single node machines or clusters. So in this case, we're actually using it on EMR, so it's on a cluster. Important things about Spark, and it's becoming the market leader in big data processing frameworks, is that it gives faster processing, and it does this by building resilient distributed data sets, which basically means the data set is spread across all your nodes and runs up to 10 to 100 times faster than if you were doing something in Hadoop like MapReduce. So Spark is a different framework, and it does this by actually using in-memory computing. So it actually stores the data mostly on RAM. Hadoop on its MapReduce instances actually stores the data on disk and then reduces it together in memory, pulling it, writes it back to disk, and you have several steps. Spark works differently. It basically tries to keep as much of it in memory or on the nodes near its disk as possible, and that gives you that faster processing framework. And then a big benefit of Spark is that it's flexibility. So you can see here that it actually works in Java, Scala, R, or Python. So it really opens the possibility for data engineering that, you have multiple languages, at least 3 that you probably want to write in: Java, Scala, or Python. And then it also opens it up to your data science team, mainly through Python and R. So you end up with this ecosystem of frameworks that everyone understands, and you're getting the benefits of faster processing through that in-memory computing. With that being said, let's jump onto the console, and then we'll actually go through the workshop on the Spark section, and that'll include some CLI execution, some notebooks as well. So join me on the console. So in terms of this section, we're going to do the third part in the series where we do a CLI job execution after we set up this S3 bucket that I'll take you through now. I'm going to show you how to monitor your jobs. We'll have a look at the Jupyter Hub notebooks. We'll have a look at the EMR notebook, and we'll have a look at EMR steps as well. So the first thing we're going to do is set up that S3 bucket. Okay, so the first thing we need to do is set up an S3 bucket that we're going to use throughout the rest of this tutorial. So let's go to S3 and type it in at the top. And once on the S3 console, we will go to create bucket. Now, your name has to be unique throughout the entirety of AWS. So I'm going to use my name because it's usually unique. And then I'm going to call this EMR. So it should be unique within my account. Make sure you're in the same region that you have set up your EMR cluster in. So for me, that's US East 1. Leave everything else as default and hit create bucket. This will take a few seconds. Once the bucket is created, go to it. So I just type in EMR and there is my bucket. And then we want to create a couple of folders. So in terms of creating the folders, we want to call one files. Great. We want to create another one called input. We want to create another folder called output. And we want to create one called logs. Create the folder. So we should have files, input, logs, and output. Then in the input folder, click upload, and we want to add a file. And we need to go to that folder that we unzipped in the setting up lesson. So in the setting up section of the video, we have our EMR 0 to hero main folder. And in there, you will find a .csv called trip data. So tripdata.csv. Open that and upload. So we're uploading that .csv to input. That's coming from the folder that we downloaded in the first section. And don't forget that folder originally came from GitHub. Okay, that's our data uploaded. So we just hit close. And if you have a look in input, you can see that the CSV data is now there. Okay, on the Cloud9 instance, so that's over here on the Cloud9 instance, back on the Cloud9. Once on Cloud9, if you hit up, you'll find your SSH command. So it's ssh-i./emr.pem, Hadoop at, and then the IP address of the master node. You can see that my master node IP can be gathered from here. And we hit enter. So it's the same command we used to log in earlier. And that is just logged into the EMR instance. Next, we're going to use a nano text editor to copy and paste some code in. So type nano, N-A-N-O. And then after that, we need to give a name of a file. So we're going to call this spark-etl.py. So that's spark-etl.py and hit enter. This will open a text editor. If we go to Bitbucket or the folder that you've downloaded, you'll see that there's a file there already called spark-etl.py. You want to click in or open that file, and we want to copy the contents of that entire file. And we want to paste that back into our Cloud9 instance by hitting Control or Command V. Just copy and paste in using command line. Then we want to save this file by hitting Control X, then hit Y for yes, and then hit enter. And that will have wrote that file. So if we hit ls, you'll see that there's now a file there. If you type cat spark, S-P-A-R-K, and hit tab, you'll see that it'll cut out the file for us, and that is the file that we have created right there. Then there's a couple of commands we need to run here just to export a few things. I'm going to type in clear to get rid of everything off my screen. And then in again to the GitHub. Back out of this file, you'll see that there's Spark commands. Click on the docx file and you'll see that there's 3 commands on 3 separate lines. Copy and paste the first one. So I'm just going to take that, copy into my Cloud9 instance, which is here. I'm just going to drag this closer. I'm going to right hand click and paste. I want to allow that paste and hit enter. Then we need to get that second command. So I'm going to go back in. I'm going to highlight the whole thing again. Going to copy, paste, and hit enter. And again, that'll copy and paste that second command. I'm going to take the third command. Now, there's a couple of things we have to fill in. See here, as you can see, there's going to replace this your bucket with that S3 bucket. So we're going to copy that in. I'm going to take a couple of new lines just by hitting enter. You want to paste what we have. We want to go to S3 and we want to copy the bucket name. So I called mine Johnny Chivers with EMR. You'll have a different name to me, obviously. So copy your name of the bucket. And again, I just want to copy that. Back into Cloud9, hit the arrow key to go back along the line. So that's my left arrow key. Get rid of everything between the greater than and less than sign and put in your bucket name. And then again, what we want to do is go the whole way back here and get rid of that by hitting delete and then paste in my bucket name. Once I hit enter, which I did accidentally, it'll start to run as you can see on screen. So just hit enter once you paste in that second bucket name and you'll start to see this is all the information being passed out to the logs. So this is all our logging information currently, and we get a full access to those logs here and then when it's done as well. So this is all the logs, all the info, how it's starting up, and it's running our first Spark job for us on ETL. That was the data frame that kind of just quickly went across the screen there. Let's see if I can grab it. If we just scroll back up, you can see that's printing out rows of the date time. Back into the S3 bucket now, and what you'll actually see is that we came from input, which is the trip.csv data, which is what we had to change during that name of the S3 bucket. So you can see that we were going from input to output /Spark. So that means we go output, we should have Spark, and then you should see that we actually have a Parquet file sitting there. So we successfully changed the data from CSV to Parquet. Okay, another way to see your logs, and I'll show you quickly, is that if you go on to the EMR console, you go to Application User Interfaces, and you go to Spark History Server, which is here. If you click on that, it takes a few seconds. Okay, so we'll just leave it for 5 minutes and eventually some logs will appear. The next thing we're going to do is the section C in this Spark-based ETL, and we're going to upload a Jupyter notebook, and then we will actually type some commands in to get that running. So what we need to do next is take the name of our master IP or our master IP address, which is this here. And in a new browser tab, I'll just use this one, we need to type in https:// copy and paste in that master node :, and then we want to go to 9443 and hit enter. This will take a few seconds. Okay, if this happens, what you need to do is type in the phrase "this is unsafe" into the browser without touching anything else. So if you type in THISISUNSAFE, this is unsafe, it works. So you can see up here now it's changing. So I literally typed in the phrase "this is unsafe," but like just on the screen itself. So if you type in that, you'll get around this browser issue that comes up that it's unsafe. In terms of username and password, if you jump back onto the document, we're in section C now, and you can see that the username and password is supplied for you. So you just want to copy and paste that in. So the username is this, and the password is Jupiter. And we want to hit sign in. Then we want to create a new notebook by going new, and PySpark is what we want. And we're going to copy and paste some code into this. So if we go back onto the GitHub, go back one, and have a look at Jupyter Hub notebook code. Click into that. You'll see that there are 8 steps. Copy the code for step 1, Control C and Control V. And if you've never been in a notebook before, we're just going to run a section at a time. So hit run. That'll import everything we need and starting the Spark application. Step 2 will go in here. So we're just going to go down into step 2, and I'm going to copy and paste that in. And as you can see again, it's looking for the 2 bits of information about our bucket. So I'm just going to delete all that, go to my S3 bucket, go back out to the top level, copy and paste this in, back onto the server. Oh, it's in there. We just want to copy and paste that in, and then we just want to copy and paste that in there. You can see that the application is available as Spark. So we start up a PySpark application, and it's the current session. Again, hit run when we've done that. It's just assigning 2 variables, so that won't take very long whatsoever. Step 3, we're getting the NY taxi driver data or taxi trip data, and we're actually reading this up from the input path location. So input path location, and we're reading that data up. We just want to hit Control V and hit enter, and it will start back and hit play, and it will start to read that data up. As you can see, it's in progress, so it's reading the data up for us. Whilst it's doing that, we'll get step 4, and this will actually count the data for us. So because that in progress is finished, it now has the data in memory. So we've started the application, we've put our input and output paths, and we've read the taxi data up. That'll actually now count the data that we've just read up. You can see it's 2000, like the logs we saw before on the console. This will show the data, so this one's always a good one to look at. And again, you just want to hit run when ready. And there is the data as a little data frame. As you can see, it's just the top 20 rows. Then we want to print the schema. So this will actually show us what the schema looks like for that data, for that NY taxi data. And again, hit run. There you go. Starts with vendor ID, ends with trip data, and it gives you the nullable and the data type. Back in, and then here is how we add a date time column to the data. So you can see with column, which we're going to call current date, we're going to give it the date time now. So we're adding an extra column called current date, and it's going to be date time now. And if we run that, it'll actually append that column really quickly. And then to see that column in action, hit Control V and hit enter, and then run, and you see the new column has been added to the data. Okay, I'm not going to do the D part of this. It's exactly the same if you want to follow along at home, where you create an EMR notebook instead, and then you actually copy and paste in the exact code and get the exact same results. It's just 2 different ways of doing the notebook. I'm just going to leave it, but feel free to go to the document here and work your way through it if you want. EMR steps I will do just to show you how this works. So what we need to do is go to S3, as you can see by the instructions. So back on S3, we want to go to the files folder, and then we want to upload. And this time we're going to add a file from the folder that we downloaded at the start. So click into that folder, go to the Spark EMR steps folder, and click on the Spark EMR-ELT.py. This is different than the one we created before. You'll notice that it's got an override statement and override. So that's the difference between this file and the one we created previously on the console. So this is a different file sitting in a different folder. It's just called the same thing. So we're just going to open it and we want to hit upload. Then we want to close that and just make sure the file made it. It did indeed. Then we want to go back to our EMR cluster itself, which is over here. And I want to go to EMR clusters, which is here. We want to click on that steps box, and then we want to add a step. And you want to give this a name, so custom jar. Then for the location of the jar or the command that we're going to run, you want to type in command hyphen runner jar. So command hyphen runner jar. Then if we go on to the heroes and zeros, in that EMR folder, that Spark EMR steps folder that we were in locally, there's a commands.txt, and you want to copy that command.txt out of there into arguments, and you want to change bucket name here to the bucket name that we've been using all along for EMR. So EMR bucket is my name hyphen EMR. So if I copy that and then back onto the EMR console, and then I also just want to replace the bucket name with my actual bucket name. So I'm just going to go like this, and that should be us. Hit add. I've had a few failed attempts trying to get this to work, but it should work now. Spelled the name wrong, but that won't matter. This will take a few seconds to run, so I'm just going to pause the video here, and then we can pick it up once it's ready. Okay, I actually had to start another one. I'll show you why. If you just quickly look at the third copy and paste of my bucket name, I actually got rid of one of the forward slashes, so it should be 2 forward slashes, and I put 1. So I restarted it and copied and pasted in my bucket name correctly, and you can see that this time there are 2 forward slashes there. So that was the problem. I just got that third command right by keeping the 2 forward slashes, and you can see that it completed successfully. In the view logs, if I just hit view logs and then go to standard out, you'll see that we got the print out of the schema. You'll see that we got the data printed out top 20 rows, and you'll see the total number of records, which is the same we had in the console, which is the same we had in the notebook. So that's it for the section on Spark-based ETL. We'll look at the Hive section next in the notebook, and we'll start there. So now we're on to Hive. I use Hive every day in my job. It's still a market leader. It's still a great way to interact with big data. And the reason for that is that Hive is a data warehouse software that facilitates reading, writing, and managing large data sets using SQL. So this SQL is actually the big selling point to Hive. Structure can be projected on the data already in storage. So you can place a table on your data that is already in storage, and then you can access it through a JDBC driver. And that's the big selling point. It offers an SQL-like interface. So you actually write SQL queries that we'll be doing when we get onto the console, and then you can actually call the data as you need. And then it works with loads of different storage types, such as plain text, RC file, HBase, ORC, Apache, Parquet, Avro, etc. That means you can place a table over your data using Hive and then interact with it in SQL. That's exactly what we're going to do in the next lessons. So let's jump onto the console and get going. Okay guys, in this next step, we're actually going to look at Hive, which is this section in the notebook, or workbook rather, if you're following along at home. We're going to do the Hive CLI, and then we're going to do the EMR steps. So the first thing we need to do, as you can see, is actually access that Hive CLI, and then we are going to do that by logging into the cluster again. So back onto my Cloud9 instance, and I'm just going to clear this screen so it's off. If you're still logged into the EMR cluster, that's fine. If not, we log back in by typing in the command ssh -i. Then the key power that we've been using all along on the left-hand side there of my Object Explorer, which is EMR-tutorial.pem. And then it's the Hadoop user, Hadoop at, and then it is the master IP of the EMR cluster, which seems to have gone missing as I've closed the window. So if I just type in EMR and open, back into the cluster, and then it's this master IP we want here that we've been using all along. Copy and paste it in, and then hit enter. Oh, I just typed that in wrong there. I can just do, rather than that, it's a dot, hit enter. Then type in Hive. Take a few seconds. And you can see now that it's logging into Hive. Configuration files are on the go. And with this little Hive and then the greater than sign, we're actually then in the Hive CLI. Next thing we need to do is actually create a Hive table over our data. To do this, there's two ways we can do it, or two places you can get what we need. Inside the main GitHub repo, if you go to Hive, then you look at Hive taxi test HQL. Let me just check that's the right one. Yep, Hive taxi _ test. So there's two files there, and make sure you go to the _ test.htql. We can copy and paste this in. Now, I'm just going to click the copy here on the right-hand side with a little tick. And what we need to do is replace your bucket name with the bucket we've put the data in a couple of sections ago. So be very careful as we do this. We don't want to run it right away. We need to update that bucket location. So back on the EMR and we paste in. Then what we need to do is change this bucket location. So we just minus all of this out. So we're here. And the bucket I'm using, as you can see at the top, is called Johnny Chivers EMR. Your bucket will be named different to mine, depending on what you called it. So it's this bucket location. And then we will be going into the input file, and you can see that our data is sitting there from the previous section. Back on to the Cloud9 instance, and I'm just going to paste that in. So you can see there, I've just pasted that in. This is going to create a table over our data that sits there. And if I hit enter, it'll take a few seconds, and hopefully it will create that table for us. Great, that's the table created. Then we actually want to look at our data, and we can do that by typing in capital letters, select, can get my caps up there, select, distinct. Then we're going to use the rate ID, capital letters again, from, and the name of the table, which we called NY taxi test. So that's their NY taxi test, NY _ taxi test, and then we need a semicolon, and we hit enter. Not text, sorry, test. And spelled distinct wrong. So DSIS capital T. There you can see it's off and running. You can see that the cluster is elapsing time as it figures out what actually we need to bring back. It's created one mapper job, one reducer, and there is our taxi IDs. It got 6 rows, and it got 1, 2, 4, 0, 3, 5. Okay, so that's one way to use Hive. The other way to use Hive is on the second section of the booklet in this on C, is where we actually submit a script at the cluster, and then that script runs and gets us out output. Slightly different way of doing it. So the first thing we need to do is go and add a step into our cluster and actually upload the file as well. So if we just jump back into the GitHub and we go back up one, you'll see that there's a second file called ny-taxi.htql. This time we're going to operate differently. We're going to upload this file to S3, and then we're going to run it on the EMR cluster directly. That file is already sitting in the zip file that we unzipped earlier, which is the hyphen one this time. Let's upload that to our S3 location called scripts, or files rather. Inside files, let's upload, and let's add a file. And let's go and grab the file that we need, which is inside here. Inside Hive, and then it's the one ny-taxi. Open that and upload. Takes a little second. Let's double check that it's arrived. It has arrived. Next thing we want to do is go to the EMR cluster again, which is here. We want to add a step to that cluster. So if we go steps, add a step. Step type, we're looking for Hive program. S3 location, well, that's easy. It's where we just uploaded that file to. So if we go files, the NY taxi HQL, copy that URI back in and hit paste. Input location, well, that's easy again. If we go back onto the S3 bucket, we go back up onto the EMR and we go to our input, which is here. If we click in, you'll see that we're going to input this data, so that's fine. Highlight input, hit copy, and we will then paste that in. And then our output location is actually not input, but output. And I have cap locks on. Output /. Now make sure you put in that / for output. Then we want Hive and we want / again. So that's the bucket location /input /Hive, and then make sure you put that other / on. Leave all other values blank and hit add. That'll start it off and running. It'll take a few seconds and hopefully we'll end up with the data outputted into that output location once it's done. Okay, so that took about 30 seconds, and as you can see, it was completed successfully. And the other way to check this is by going back into the bucket, clicking up one, going to output, going to Hive, and then we should have a file of output, which is here. So that's it. That's how this works for Hive at a very basic level. Join me in the next section and we'll move on to Pig. So we're going to take a look at Pig now. Pig is going out of fashion slightly because it is slower than Spark, but I do know of at least one multinational enterprise company that does the majority of their data processing on Pig still to this day. And the way it works is an abstraction of MapReduce, which integrates with a lower level Java API, And that Java API and MapReduce framework is actually what makes it slower. So it's writing to disk and then pulling the data together as it does computations. It does store the same, or it does work with the same type of data as Spark. So, I've mentioned it before, Orc, Parquet, plain text, CSVs. But what it does give you, or what it did give you originally, was parallelization, but in an easy manner. So it let you actually create parallelization over your data without actually having to write the low-level Java code that you would need otherwise. And that's why it was popular before other frameworks came along. So it was one of the originals, and that's why it's still used today. So let's jump onto the console and get going with Pig. Okay, in this section, we're going to look at Pig. The prerequisites are already covered in a previous section. So we can just jump into section B, which is Pig. If you look at the GitHub and you go into the Pig folder, you'll see a nytaxi.pig script. And again, I've already downloaded this locally onto my desktop. First thing we need to do, the same as we did previously with Hive, is upload that script to the S3 bucket. So back at the main directory of my S3 bucket, into files, and here this time I'm going to upload. I'm going to add a file. We need to go back a couple of directories. So EMR 0 to 0, or 0 to hero rather, Pig, and then the Pig script. We want to open that and we want to upload. This will take a few seconds. Perfect, that's it uploaded. As you can see from my files, it's sitting there. Same as before, back onto the EMR console, back into steps, and this time we want to add a step, and this time it's a Pig program. And again, we need to specify the S3 location, input location, and output location. So the script is back on S3, and it is the Pig script, so please make sure you're getting the correct one. Copy the URI, and then we'll just delete that out and paste it. The input location is the same that we've been using all along for our data. So it's in input, and then we have the CSV file sitting there. So we just want that input location URI. So take that and paste it into input location. Output location is / out of the folder. So I just pasted and deleted input. Output, again, output, and then /pig /. So make sure you have that n / or it won't work. And this time we're putting it into a Pig folder in our output folder. Add the job, and that's it off and running. It takes about 30 seconds to run. And as you can see, that status has gone to complete. And we can check that it worked by going back into the S3 bucket, going to output, and this time going to Pig. And you can see that we have parsed out that Pig, or that's data of CSV using the Pig script. Okay, I'm actually not going to do section 6. It's pretty basic where you set up a EMR notebook and then there is a um, Jupyter notebook that you insert and then run some code on. If you want to follow along, I have put the Jupyter notebook into the GitHub repo under EMR Spark notebook if you want to do it yourself, but it's very simple. You're literally just running a couple of Python commands that AWS have set up for you, as you can clearly see. So there's not really much to learn in terms of EMR. All the code's actually done for you, but if you want to do some modeling or play along, then feel free to do that next section yourself. I'm actually going to jump on the step functions because I do use these in my daily life inside EMR to orchestrate things, and then we'll do auto scaling. So those two things are more important in terms of EMR infrastructure. This is really data science and not really data engineering. So if you were a data engineer, you would hand this off to your data scientist normally anyway. So I'm going to focus on the things that are important to data engineering. But if you want to carry on with this bit of the course yourself from the AWS workshop, feel free. All the resources are there. Okay, now we're going to take a look at using AWS Step Functions to actually orchestrate a couple of steps in our cluster. As you can see on the right-hand side, we're basically going to use them to add a Spark step, add a Hive step, add a pig step to our cluster, and then run them. And it's a low-level code way of building a workflow that is actually event-driven. So when one event happens or numerous events happen, do another event. And AWS really pushed these because it makes it easier to manage failures, retries, parallelization, service integrations, and observability, so developers can focus on higher-value business logic, i.e. they take away the orchestration for event-driven data loads and then let you focus on actually developing those ETL scripts. So with that being said, let's jump onto the console. This is really one that you have to do to get the hang of, but we're essentially just building steps inside a function that's going to add things to our EMR cluster. Okay, in this next section, we're going to look at orchestrating Amazon EMR with step functions. As I said, this is something that I do in the daily life as a data engineer for event-driven stuff, so it's kind of important. We're going to start a state machine. We're going to use a couple of JSON files that are provided for us. We're going to use the scripts that we've been using so far, saved into our script location on S3, and we're going to create a state machine that does a couple of steps for us so we don't have to actually do that much anymore, but a lot of this is handled for AWS inside these JSONs that we're about to provide. So with that being said, let's get on and let's actually create a state machine. Back on the AWS, I'm just going to select this tab and we want to go to step functions. So if you type in step functions will come up. And then we want to create a state machine, which is here. And then we want to click with your workflow in code. It will be standard. And then we're going to copy and paste the JSON in that we need here. So I'm going to delete that code out and we're going to look for the SFN JSON in the GitHub repo, which you can see is right here, snf.json. You want to click into that. You want to copy that code when the green tick appears, and then you want to go back into step functions and paste that in this time. So you can see that we're pasting in the steps. Feel free to read through this with AWS, but there's a nice little visualizer on the right-hand side that tells you what's going on. We're going to add a Spark step to the EMR cluster. We're going to add a Hive step to the EMR cluster. We're going to add a pig step to the EMR cluster. It's then going to process them all and then disable the cluster once it's done. Then we want to hit next. Then you want to give your state machine a name. So I'm just going to call this Johnny EMR steps. That'll do. Leave everything else as default and create the state machine. So just everything is default and create state machine. This will take about 3 seconds and you can see that it's successfully created. Just going to minimize all of this. Then the next thing we want to do is actually execute this state machine. Okay, so we're going to have a little bit to do here. So our input that is optional, we actually do need the input, and that is back onto the GitHub repo. And you want to go to the args.json and you want to copy that JSON. You then want to go back on and paste that in. And then you can see that we have a couple of things that we need to change. The first thing we need is our cluster ID. So back onto the console, back into the cluster, and you can see that we have a cluster ID right here. So you want to copy that, and then you want to paste that in there. And let's just double check everything came across. It starts in J, R ends in U. Perfect. Then we need to update all this S3 bucket names with our S3 bucket name, and there's quite a lot here. So back onto the S3 bucket, because I always just find it better to copy and paste. Back onto the bucket, and I'm going to copy and paste the name. Your bucket name will obviously be different than mine. You also have to have done the pig, the hive, and the spark steps for this to work, because we're going to be lifting the code from where we saved it earlier in that S3 bucket. So make sure you've done the previous lessons before you come onto this stage. And what I mean the code, if you actually quickly look at that S3 bucket, where I'm struggling along the top there, in the files, you'll see that we have the file sitting here that we're going to call, and that comes from the previous lessons. So back in, and we just want to copy and paste in the name of our bucket. Make sure we only delete that bucket name. Don't want to mess something up with a random / missing or an extra /. Very easily done at this stage. It's simply a copy and paste job in to remove that S3 bucket. You want to leave that delete cluster as false for now, because we're not going to delete the cluster, and because we need it again, so just leave it false. And once you've copied and pasted in and you're happy that you know that everything is in that scripts folder, you want to hit start execution. As you can see, it's off and running. So a blue step is when it starts and is about to go, and then a green step is when it's actually added it to the cluster itself. It'll do this step by step. Green will mean it has succeeded. Okay, that's been going about 30 seconds or a minute so far. You can see that the first section has completed. I'll pause the video again, and then we'll pick it up once the whole thing has gone green and succeeded. Okay, as you can see, it was successful, and we had that terminate cluster stage set to false. Now, I will point out in the booklet, there is another section in B where you can redo the same thing, but what you want to do this time is delete the cluster. I am not going to do this section because I want to do the auto scaling section, and if I delete the cluster, then I need to respin up the cluster. But this time, if you really wanted to actually do this section and you don't want to do auto scaling, then in the JSON, when you go to start execution, this false, change it to true, and instead it will go down the right hand side to green. So change the false to true, and then you'll see this right hand side go green, and you'll have no cluster left if you follow along. But for me, I'm going to do auto scaling, so I'm not doing this section. Okay, last step in the workshop booklet is EMR auto scaling. So hopefully you are aware of what auto scaling is on your cloud journey, but just in case, it's where you actually scale up or scale down a cloud resource, in this case the nodes on the EMR cluster, based on a set of defined rules. And then you can take them away, as I said, scale up and scale down also on a set of rules. So we actually add auto scaling policies to the EMR cluster, which we're going to do in the next lesson. We define how those nodes should be added or removed. There are tons of options of how to do this, including RAM, disks, number of apps running, number of apps pending, number of apps failed. You'll see a whole drop down when we get there. But essentially what we're doing is creating a policy that says, hey, give me more nodes when I have something going on that requires more resources, and take those nodes away when I don't need them anymore on demand. And obviously this improves both performance and cost optimization. So join me on the console and we'll get started. Okay, now we're going to do EMR auto scaling. So there's a bit to this, there's a bit of setup work, and then we're going to use a state machine basically to fire off some data and start some workloads, and then obviously get the cluster to scale. Okay, so there's a bit of work here. It'll take us a while to set up, but not that long to auto scale itself. So the first thing you can see by the booklet is we need to go on to the EMR cluster. We need to navigate to the cluster that we created, which I'm already on. And then you want to go to the Steps tab, as you can see. And then in the Steps tab, we want to change, and I mean change the concurrency level, which is currently at 1 to 5. So up that to 5, which means we can run 5 steps at the same time. So concurrency needs to go to 5. And make sure you click that tick to save it. Okay, the next thing we need to do is actually set up the cluster scaling policy. So I'm going to go back a page. Oh, and click in again. Sorry, my bad. Click the wrong thing there. Just click in and go back to summary for now. Back onto hardware. And then you can see that there's a cluster scaling policy. You want to hit edit on that cluster scaling policy. Funny enough, you want to create a custom scaling policy ourselves. Then you want to hit this little pencil icon to edit, funny enough. And you want to then create our own instance policy. So we're going to hit 2 for minimum, 5 for maximum. We want to scale out. So we hit scale out. We want to add a rule. Our rule name will be add node. You want to add one node. And we're looking for apps running. So apps running is greater than or equal to 2 for 1 5-minute period, and we want to cool down after 60 seconds. So add node, add one instance, apps running, greater than or equal to 2 for 1 5-minute period for 60 seconds. And then we want to add a scale in policy. We want to add a rule. Rule name, we will call remove node. We want to terminate one instance if apps running, so again, apps running is less than 2 for 1 5-minute period and 60 seconds again. So remove node, 1, apps running, less than 2, 1 5-minute period for 60 seconds. You want to modify, and you'll see that it's gone pending. This will eventually go attached if you refresh a couple of times. And we'll just have to wait a wee minute, and this will go to attached over pending. Okay, I've refreshed that a couple of times, and it has now went attached. So the next thing we need to do is a state machine again. So back into Step Functions, which I'm just going to take on a new tab again. We want to create a state machine. We want to write our workflow code in. We want a standard workflow. And we want to copy and paste from the EMR -SNF file. So EMR this time -SNF. Copy that. Then we want to go into the state machine console, remove that code, paste it in, and hit refresh. And you can see now that we have this pattern that's going to carry out to auto scale for us. Click next. Give this a name, so I'm just going to call this auto scale state so I know what it's doing. Create a new execution rule and leave everything as is. Okay, the next thing we need to do is go to our S3 bucket that we've been using and go up into the output section, or this section here that has the output folder and file. Highlight both of these and delete them. And then we just want to permanently delete these objects. So we're deleting the output locations because we're going to create them with our state machine. Okay, that is those deleted. Back into the state machine itself, which is here. We want to start the execution. You guessed it, back into GitHub. Then we want this file called EMR state machine. I've lost the place arguments file. We want to copy that one, and we're going to paste it in here. And again, we've got a big job on our hands, so you can see that we need to change the cluster ID again. So back onto the EMR cluster, back onto summary, and we're going to grab the ID, and that gets replaced here. And then the S3 bucket again, we need to change over. So again, it's the same name of my S3 bucket. Yours will be different, and we actually need to replace it everywhere that it says S3 bucket name. Funny enough, which is quite a lot. Take your time with this because, again, it's really easy to mess this up by deleting an extra forward slash or leaving in one of the greater than or less than signs. That's easily done. So take your time, and it means that we should get this right first time. So again, we're just deleting everywhere that says S3 bucket. You can clearly see how much there is here as well. Quite a lot. So there's all of that done. And we have to do the Hive args. Okay, quite a lot there. Just make sure you get it right in the end. Just make sure you get that correct in the end. Then we want to start the execution when that is ready. And we have started. Back onto the EMR console now. And you want to go to monitoring, and what you're looking for is this apps count increasing. So this will take a minute, and then that apps count is going to increase. When the apps count increases, our hardware will start the auto scale. So I'm just going to pause the video here for a couple of seconds, and then we'll pick it up once we start to see these things happen. Just wanted to point out a couple of things here. As you can see, there's a lot of pending jobs on this cluster right now. And it's these jobs that are going to run and then cause the cluster to auto scale. So that's what's going on. We're basically putting all these jobs onto the cluster, and it's going to cause it to auto scale. And you can see that in the steps section. So I'm just going to go back to monitoring for now. Oh, and you can see that the number of running apps is starting to increase. So this is going to start to cause the auto scale for us in a little second. And you can see that it's still running at the moment, but at some point, this is going to go to resizing. What? Yeah, there you go. You can see that the cluster is now resizing up to 5. I actually missed as it was resizing a couple there, but that's it now auto scaling up finally. It took a couple of minutes and that's it started to work. So that's how auto scaling works with policies. As I gave you the example, we're using apps, but you can use memory, you can use disk to auto scale, which would be more common. That's it for the size of the practical. Join me back on camera where we'll just run over what we've done today, and thanks very much for watching, guys. Congratulations, that's the end of the course. We've done a real deep dive into EMR. There's a lot of things to take in, but I'd really appreciate if you continued to watch some videos on the channel. I think the glue one would be of particular interest, link above me now somewhere. And then a like and subscribe to the channel would really help me out. I want to make this content for free, but I can't do it without the subscribers and the likes. With that being said, there's also a link to my website below if you want to reach out and contact me. And until next time, guys, thanks for watching.